All right, let's look at the top monitor. So you'll notice that this doesn't quite match our diagram. We have these gaps between our viewport areas. This gap here and this gap here, it's probably 9 pixels, I'm gonna guess. So looking at our code, we can see why that is. So you can see that we have it adjacent here and we've measured everything out. However, in our formulas, right, we have the -1 right here. So, right, all these -1s because we're snapping to these tiles, right? But we've scaled everything by 10. So these -1s kind of end up becoming -10s, right? And that's why everything's not quite lining up. That's fine, right? Because we see the basic shape. It pretty much matches the diagram enough where you can draw the connections, and it's not really important that they are tangent. It's just important that we have these different viewports of different sizes that are on the canvas, and they aren't touching up against any of the edges of the canvas. So I'd say that is good. We got our little viewports. Now, the next thing we want to do is draw some type of sample pattern in our source viewports, I guess. The viewports viewport 0 is going to sample from this viewport, and then this viewport down here. So we want to have something to sample, to get some feedback. So we want to draw something in here. So what are we going to draw? I say we just draw like a ring, we don't got to get too complicated. Let's do that. But how are we going to do that? I guess we would need some type of draw default pattern, whatever, using viewport and canvas adapter or something function. So we know that something like a function we'll call it fill viewport with test pattern. And the viewport with test pattern, it's going to take the canvas adapter, and then it will take a some type of bounding rectangle. Okay, so that's the signature we're going to go with for this function. Clean up our indentation a bit. How are we going to do the logic for that? I know I'm going to do kind of like a, I'm going to take all of this code right here. We're just going to paste that in there. Then we're going to take the apply, we're also going to take that, or put it outside of the loop. And then it is getting a bit annoying. Let me think about it. Okay, yeah, I'm gonna, because it's getting annoying, I don't want to add those extra lines of code all the time, so I'm just gonna inline it like this. Okay, so there's our bounding rectangle, and then its input in there. We're going to loop over every single pixel, but instead of just putting down a flat color, we want some type of formula to kind of draw like a ring. So a ring can have a inner diameter and a outer diameter. And that inner and outer diameter should probably be based on the size of our bounding rectangle. So let's say something like var outer diameter equals something like math dot min, and then dot x1. Actually we'll do var dx delta x equals math dot abs dot x1 minus rec dot x0. Okay, so we'll take the delta x and delta y to get the kind of like the widths and height of our rectangle region. Change that to y, change that to y. So delta x, delta y, and we want to make sure that our shape fits inside of the viewport. So we're going to take whatever side is smallest. So the math.min dx and dy. So that's going to be our outer diameter. And then for our inner diameter, we can just like make something smaller, but we don't want to accidentally go past 0 by just subtracting. So we're just going to do division, which will guarantee us to get something smaller without making our values go negative. So var, and it's going to be our inner diameter, equals the outer diameter divided by 4, let's say. Okay, so we got these diameters that are going to define our shapes. Is that correct? Yeah, that's good. So the math, we're going to use radiuses. Do we need a variable for radius? Do we just want to change this and make these radiuses? Sure, let's make them radiuses. So we'll just go like that. And then we're going to take all this code right here. We're just going to go like this and say divided by 2. Remove these semicolons here. Okay, that looks good to me. The outer... oh, actually, this is already... divided by 4. So actually we'll do equals outer diameter, outer radius. Actually, it's just I don't know. Whatever, it doesn't really matter. Okay, so we got our outer radius, we got our inner radius. The inner radius being smaller. And we need to figure out if a certain pixel we are sampling is either inside or outside of the ring. So to do that, we're going to use some distance formulas. And the distance needs to be less than the outer radius, but more than the inner radius. Okay, so var dst equals... it would be the square root, math.square root, and it's going to be the square root of the sum, of the squares of the deltas. Now, that's a mouthful. Let me just show you what I mean. So the deltas, when we're using the delta of what? So we want this ring to be in the middle of the canvas. So it's going to be the delta between where the pixel currently is and the center point. So we need to calculate the center of the canvas really quick. So var center x, actually I'm going to call it cx, equals the bounding rect dot x0 plus the bounding rect dot x1, and then just divide it by 2, right? So we take the 2 points in space, and then when we average them out, it gives us the midpoint between those 2 points in space, right? So let's take a cy, same deal. So the y0 plus the y1, right? And it doesn't matter what order this is in, right? Because with addition, you can do it in any order. Okay, so there's our center points. Center of Viewport. Okay, so now that we have that, we're gonna do our distance formula. So math.pow, and then we're gonna take the deltas. So it's gonna be the difference between the center point and x, and then math.pow. Did I say? So I may have said the wrong thing when I was explaining this, but now I'm writing it in code, so it should be obvious. Okay, so this is the delta of the current x position we are sampling, right? Because we're going to scan through every possible x and y, and we're going to say and we want to say how far that pixel is from the center point, right? So here's the center. Actually, this is the center, right? Because it's 2 variables. Here's the center, and here's the current pixel we're sampling, right? And this is how the distance formula works, right? So we're just going to do this to the power of 2. We're going to do this to the power of 2. Oh, as I'm explaining that, it makes it obvious. So, right, we're going to do both of these to the power of 2. Then we're going to add them together, and then we take the square root, and that should give us the distance if I, remember my math correctly. And then we want to decide, okay, is it inside or is it outside? So if dst is greater than or equal to, so even if it's on the border of the inner radius, and dst is less than or equal to the outer radius, right? Because the outer radius is larger. Okay, so another way you could write this, if I actually like to write it more this way. So I'm gonna, well, it's a little bit more, I don't know, it's just, I'm gonna show you, and you can either love it or hate it. So our lower bound is the in-rad, right? And then we know the point needs to be greater than the inner radius. So dst needs to be greater. So the cool thing here is when you're reading something like this, inner radius is less than or equal to distance. That can kind of be confusing to read until you read it backwards, right? So you can read it in this direction. So distance is greater than or equal to inner radius. And the cool thing about that is because then you can write something like this. dst, and the reason why I like this is because it reads that this source code now kind of reads like this, like in rad less than or equal to dst less than or equal to out rad, right? So you can't actually write it like this, but this is pretty close though, right? So now when you're looking at like mathematical formulas on Wikipedia, a lot of times they write stuff like this, and so now this that you're going to see in mathematical formula documentations is going to like more closely match what the source code looks like. So I like that. So anyways, if we are inside, right, so we'll just if point is inside, I want to call it tube, and whatever, ring/tube, whatever, ring/tube, color. Okay, and make sure this is right. So it's greater than the inner radius, but it is less than the outer radius. And then we'll take this here. I'll take, and we'll just color it. How about we color it a dark red color? Maybe we still want to use color for the other channels, so we'll just, like, you know, I don't know, just put something there. What else? Let's make that a little bit more compact, so you can see everything. Okay, so I think make that a little. Okay, so let's review this really quickly. We got our function to fill with a test pattern. We got our canvas adapter. We got a bounding rectangle. We're going to take the delta of the bounding points of our bounding rectangle to kind of get like an inner and outer radius that's going to fit within our rectangle without leaking over the edges. Then we're going to get the center point of the viewport, which is in the comment, and we're going to iterate over each pixel. So iterate over each pixel of viewport, right? So X and Y, right? We're gonna get current pixels distance from center of viewport, and let's make that shorter so it fits. Okay, that works. And then we're going to do a little test to see if that pixel is inside the ring, and if it is, we're going to put down this color, and then we're going to apply the changes down here. I usually would, you know, do that. Whatever, I can keep it this way. So you've seen all of the code. I'm sorry that it doesn't all fit on the screen at the same time. Actually, here, I can do this for you. So there's the function. If you want to pause right now and take some notes, you can. All right, now let's move on. I believe I'm not calling this anywhere yet, so let me make a quick check. Nope, I'm not. Let's go over to our page. Let's refresh, make sure I didn't do any horrible syntax errors, and we got a white screen. I probably did something syntactically incorrect. Yes, I did. Let's figure out where I made my syntax error. Unexpected number. Outright. Oh, how the hell? Oh, so maybe while I was editing this, I forgot I forgot to put a division symbol. I don't know how I did that, but sometimes I do stupid things. Okay, so now we see that still, so everything's still there. Let's go back to our code, and we need to like call that somewhere. So let's go to our main function at the top, and we're going to keep the viewport fill test because we got some nice contrast. Fill viewports with test pattern. So right now I'm seeing a problem, which is where are my the viewport fill test is holding on to those viewport rectangles, and I think that's going to create some problems for us. I mean, we could just recreate those objects and it would be fine, but that's kind of ugly. So a rectangle package goes here, and let's go to the viewport fill test really quick. So there's the canvas adapter and bounding rectangles. The rectangle package is right here. So what we're going to do is we're going to take that, we're going to cut that out, and we're going to have that as a parameter. So the rectangle package here. Now we're also just gonna, you know, since we're here, we're gonna say if not rectangle package, then we're just gonna throw an error, input null, just a little note to let us know what we screwed up there. And then we're gonna go up to that function call site, and we're gonna put our getter for the rectangle package right up here. And then in the viewport fill test, we can call it like that. Okay, so let's see if I did a lot of changes, but let's see if everything looks good. So I don't have the filling the viewport isn't working, but it looks like everything's still showing up here. Let's hit F12 and do a hard reload just in case you know the changes didn't persist. Sometimes I'm paranoid when it doesn't break. Okay, so that is not quite as expected because our test pattern didn't quite work. So we got our canvas adapter and we have our rectangle package. So let's look at this code, figure out what we screwed up. The first thing I want to do is I want to check out the debugger again, make sure that there's nothing sources, so it doesn't look like anything's going on wrong. I'm gonna put a little breakpoint at this check, and then I'm going to nope, that's okay. Then I'm gonna empty cache, hard reload, and then I'm gonna go back to my dev tools, and what the hell, it's not even in there. Okay, so that's a thing. Let's put breakpoint there. Let's go back here. Empty cache, hard reload. Okay, so we've paused. I'm gonna put another breakpoint right here. Okay, so now Balrec. Oh, okay, yeah. Because it is I'm saying that the input is a bounding rectangle, but I'm actually giving it a rectangle package, because you can see from the data there. So that's one of the disadvantages of, you know, not having strict typing. You can screw things up that you would just never screw that up in a strongly typed language, because it just wouldn't let you. So what we're going to do is we're going to go back to the function call site. And this thing that says rectangle pack, right? That's not a rectangle pack. It's a bounding rectangle. And technically it's going to be like rec pack dot. I don't remember exactly what viewport it was. I don't remember, but let's just say rec VP. It's not 0, right? But I believe 3 was our biggest one. So let's do this. And then a little comment, we can make a note that the type of this rectangle is this. And there's not a 0 there, is there? It's VP3 like that. Okay. So now we're sending the right type there. And if we go back to here and let's empty it stop and empty cache hard reload. And now if we hover over this, okay, that looks much better in the debugger. I'm gonna close the debugger. Look at that, isn't that nice? We have our ring, all right, and it's tangenting the edge as I thought it would, and then we divided by, I believe, 4 to create the inner radius of our ring. Excellent. So I'm going to take a bathroom break, so I'm going to pause because this is a good point to pause at because we got our little ring in our viewport. And then when I come back, what we're going to try to do is we're going to take this viewport and we're going to try to sample from here. But actually, before we do that, we might as well take this call here and we can just like cut and paste it 2 more times. And we know that we want to do it to viewports 1, 2, and 3 because viewport 0 is going to be our viewport that samples from the other viewports. So we've cut and pasted that. Let's go back to here. Let's refresh. All right, cool. So we have, in this area that does not have a ring, this is viewport 0. And what we want to do is we want to scan this rectangle and put the results into this rectangle of a different size. And we want to do the same thing with this one. So we want to basically do it with the larger one, a larger rectangle to a smaller rectangle, and a smaller rectangle to a bigger rectangle. and I don't know. I forgot what. I think this might be called like an affine transformation or something along those lines from what I was reading. Maybe that's what it's called. But anyways, okay, I'm going to take a bathroom break, and then we'll get back to this and start trying to sample and map to this viewport here.